Green's map, dating from the late 18th century, shows the River Medlock meandering across its floodplain between steep banks. Large houses stood on the south side of Granby Row with their gardens terraced down to the river. On the neck between two river meanders stood Garrett Mill. Although this water-powered cotton mill is long gone, its access road provides the alignment for present-day Sackville Street. By the early 1830s, there were a number of steam-powered cotton mills in the area, along with many terraces of back-to-back workers' houses. Parts of the water-powered cotton mill remained, but had been adapted for use as the old Garrett Print Works. One building from this period still in use today, though it has been much altered, is the cotton mill on Jackson Street. In the mid-19th century, the brickwork railway viaduct was built parallel to Granby Row. The viaduct bridged a meander in the river via two skew arches. These arches, with their stone voussoirs, remain a distinctive feature of the structure today, although they no longer span the river. After the Second World War, industrial activity in the area was in decline. Most buildings on the site were assessed as dilapidated with little useful life remaining. Demolition and clearance in the 1950s was followed by construction of the Mancunian Way and the development of the UMIST campus immediately to the north. Buildings completed in the late 1950s and early 1960s included Staff House, the Reynolds Building and the Parisa Building. Jackson's Mill was also refurbished for university use. Piled foundations were used for the Reynolds Building. For the Parisa Building, pad and strip spread footings were used at basement level. During the campus construction period, the River Medlock was diverted from its open channel between brick retaining walls into a reinforced concrete culvert. Here, the original river course is pictured west of Sackville Street, crossing what is now the site of the Western Building and the Manchester Conference Centre. The area to the west of Sackville Street was developed later. Charles Street was realigned, and the River Medlock was diverted into a reinforced concrete culvert. This created space for the multi-storey car park, for the Faraday Building completed in 1967, and the George Begg Building completed in 1974. In the early 1990s, the Western Building was constructed. The 5-storey block on the corner of Charles Street and Sackville Street is of load-bearing masonry construction with precast concrete floors. The remainder of the Western Building has a lower floor level. A steel-framed platform supports 5 stories of load-bearing masonry. Differences in level are catered for by a reinforced concrete retaining wall and, alongside Charles Street, by sheet pile retaining walls. In the 1950s and 1960s, a series of site investigation boreholes were drilled across the area west of Sackville Street. The boreholes show the levels of the Bunter sandstone bedrock, shown here by contours above ordnance datum. In 1968, by chance, a cavity was encountered during drilling a borehole. This led to the discovery of a system of tunnels within the sandstone. Because the tunnels were below the present-day water table, they needed to first be dewatered by pumping to enable man access for mapping using mine surveying techniques. By the 1970s, the old industrial buildings on the Western Building site had been demolished. The resultant brick rubble and other demolition waste was used to fill and level the ground for car parking. During excavation, the loose and granular nature of the fill material was revealed. Wagon loads of unwanted fill material were removed via the Charles Street construction site entrance. Clean crushed stone was imported to the site for use in the ground improvement process. A backhoe excavator loads a dumper truck with stone from the site stockpile. Stone is then tipped from the dumper into a hole formed by the vibro-compaction rig. The stone is then compacted into place to form a stone column. The vibrating action also serves to compact the granular fill material between the stone columns. Stone columns on a 1.2 metre square grid enable an allowable bearing pressure of 100 kilonewtons per square metre to be achieved. Shallow spread footings were constructed on the improved ground rather than the piled foundations that would otherwise have been needed. The effectiveness of the ground improvement is verified afterwards by a plate bearing test. Displacements were recorded under a pressure of 300 kilonewtons per square metre, providing a proof test to 3 times working load.